Okay, now to continue the installation, we've moved up to the front of the boat, so we're on the bow now with the trolling motor, and we're going to talk about installing the SpotlightScan transducer. The SpotlightScan transducer contains the downscan or StructureScan type version picture that comes through this plug, and also the conventional 83200 sonar, which is introduced through the blue plug. Both of these will plug into the back of the locator that we're going to mount up here. So the first thing we need to do is figure out how to align the SpotlightScan transducer onto the bottom of the trolling motor. Here on the very back and bottom of the transducer are two alignment marks. Those alignment marks should line up with the skeg on the transducer. Sometimes a straight edge is very helpful in lining that up. Position it on the skeg, rotate the transducer. That's how you know the transducer is in the correct location. And then there is a strap that goes around the transducer and the motor, which we will attach there. Then the cord will be ran up the trolling motor and into the front locator. As we begin installing the cord for the SpotlightScan transducer, and this applies to any transducer cord that you run up a trolling motor shaft, we want to cable tie the cord neatly to the shaft to keep it in place so it doesn't get hung on objects under the water. If you simply use a cable tie around the cable and the shaft, the cable can rotate. But one trick is to put a small amount of electrical tape around the shaft first. If you do that, and then use cable tie, that will keep the cable tie cinched tight and will keep it from rotating on the shaft. I like to use a cable tie tool similar to this to cinch the cable tie nice and firm. Cut it off, and then the cable tie itself has somewhat of a sharp edge on it. So what I do after I finish the cutting that off is to come back, then I wrap a little layer of tape around the head of the cable tie. That makes for a nice tight application, and the sharp edge of the cable tie will not cut your leg if you happen to raise the trolling motor up and it brushes alongside your leg, your hand, or anything like that. Just makes a nice smooth connection. It's very tight and secure. Now we'll just move on up the trolling motor. Okay, we talked about running the cable for the SpotlightScan transducer up the trolling motor, and as you can see, we have attached it in a couple of 3 locations. But when we come to this joint on the trolling motor, the lower portion actually rotates independent of the top portion. So we can't run the cable tight or it will prohibit the trolling motor from rotating. So as you see before, now we have a section of tape already around the shaft up here. We have to form a loop in the wire and then test that loop to make sure that as the trolling motor rotates all the way to the left, all the way back to the right, that the cable does not get pinched or put in too much tension. We'll rotate our trolling motor, cable is okay, and we'll rotate our trolling motor all the way the other way, and the cable is loose and free. So our loop is sufficient. Our cable tie, and we're ready to go. When from this point on up to the top of the shaft, the trolling motor, if you're in shallow water, you have to lift this portion of the trolling motor up. So you have to be careful determining how far up this shaft that you would like to go with the attachment of the wire, because this portion of the trolling motor will slide up and down as you adjust the depth of the head for shallow water. So we're not going to be able to attach this cable very far to the top in order to enable full adjustment of the trolling motor for shallow water applications. Now we're going to talk about running the cable from the trolling motor back to the locator across the mount. There's a couple of ways to do this. The first way is you can bring the cable up to the head of the trolling motor and then run the cable along trolling motor cable back to the locator. Or secondly, you can run the cable across the mount and back to the locator in that fashion. One of the things to keep in mind when you're doing this is that the head of the trolling motor still has to go up and down. So if you're running it across the mount, then you want to make sure that as this head drops down, you have enough slack here. And of course, if you're hooking it up to the head of the trolling motor here, if the head is down, you want to make sure you have enough cable to allow you to raise the trolling motor up into this position. So always choose the most extreme location for your mounting application on the cable. In our situation, we're going to mount this cable down the top of the mount. So in order to do that, I'm going to loosen this. Once again, allowing extra cable to come out, and we will begin our process here. The next item that we have to mount for SpotlightScan is a position sensor. This is a NEMA device that actually synchronizes the motion of the foot pedal with the head of the trolling motor, so we can train the sonar beams to look in the direction that we want to. So with this, a couple of things: adhesive tape that is two-sided. There's a flat surface underneath the trolling motor pedal. Peel off the adhesive tape. Small lip on this device that actually goes down over the top of a surface underneath the foot pedal, locks it in place, and then the adhesive holds it in the appropriate position. When you put this device in underneath the trolling motor pedal, I'm going to pull the position sensor lever back, slide it into place, allow it to stick, and let the position lever go, and it will ride on the bottom of the foot pedal. It's a very simple installation. So now we're going to finish the configuration of our entire NEMA network on the bow of the boat. This is the baseline cable that we ran from the console when we finished the NEMA assembly at the console. We have it now at the bow. So as we remember from before, the baseline cable hooks into a T. The position sensor from the foot pedal comes out of the top of the T and hooks in to our NEMA network. And then at this point, we have used all of the extension cables and T's that were supplied with the NEMA starter kit, and also the antenna and other accessories. So to complete the NEMA network, we still have to hook up the bow locator. For that, we will have to purchase an extra T, one of those guys, and a 2-foot NEMA extension cable. And that 2-foot NEMA extension cable will go to the bow locator. So in addition to, for this entire installation, starter kit plus one 2-foot NEMA cable and one T completes the entire NEMA network. This is the terminating resistor that will go on the final end of the NEMA network. It came out of our original starting kit. Once again, RT, male to female, put together. The 2-foot extension cable for the locator. And then finally, the very last step in completing our NEMA network is the final terminator that closes the loop on the baseline segment of our NEMA. Plugs in. To terminate this end, just like we terminated the transom end, our NEMA network is now complete. In preparation for the final assembly on the front deck, these are our 2 sonar plugs. The blue plug is the 83 200 kilohertz sonar from our SpotlightScan transducer, and the black plug is the SpotlightScan transducer function. Both of these will plug into the back of our HDS-12 Gen. We'll run those to the locator. We actually, on this trolling motor, have a universal sonar built into the trolling motor itself, and so I want to spend a little bit of time talking about that option if you had the universal sonar built in. The universal sonar comes with this type of a terminating connection on the sonar. In order to use it with the Lowrance product, Minn Kota sells a universal sonar 2 adapter cable specifically for Lowrance, connects with this plug, and has the blue Lowrance sonar plug on the other end. So anytime you're doing an installation and you want to hook up a universal sonar transducer on either a motor guide or a Minn Kota trolling motor, probably need an adapter cable to go with it. Electric. And that completes our sonar cable adapter installation. One of the final steps to the installation up front is finishing our network wires and hooking up the power for the front locator. As you can see, we've drilled a 1-inch hole through the panel, which we're going to run the wires through to the other side. Now, a 1-inch hole will work perfectly if you run the wires in the right order. The first wire, which has to go through the hole, is the blue plug sonar, and it will just fit. Second, we run the Ethernet through. Will fit. The NEMA is the third wire. And then finally, the power wire, which will hook up inside the dash here, which is our blue plug power wire. Before we make any connections, we run it through from the front side. We will now connect the power wire as we did before, the black wire to a negative power source and a red wire to a positive power source. In the front of the boat here, we have a negative power source already set up, so we need a spade terminal with a negative. We'll plug in here. And then our red wire, this is the positive side. We will add an inline fuse holder. Let's splice that together. And then it will plug into the positive side. And that will complete our power installation. We now must determine how we're going to mount the locator on what type of a bracket. In the front of the boats, there are a number of different options. You can simply mount the gimbal bracket to the floor and use the locator directly from the gimbal bracket. Another option, a very popular option, is a ram mount. We have a ram mount here. This is a 2 1/4 inch ball. We're using the 12-inch locator for installation application on this boat, and for all the larger locators, really the 8-inch locators and above, you should always use the larger, the 2 1/4 inch balls. Smaller locators, the 5-inch, the 7-inch locators, probably get by with the 1.5-inch ball. I wouldn't recommend any smaller. But larger locators, 2 1/4, 5 and 7-inch locators, 1.5 inches. Gives you a lot of adjustability. Put the locator in many different locations. Of course, the mounting plate here, the gimbal bracket has a number of pre-drilled holes in it, as does the mounting plate for the ram mount. You can see we've aligned a couple of those holes and attached the gimbal bracket to the ram mount with screws. On the ram mount, when you get it into the position you would like for the locator to be, you simply tighten it down and it holds the locator securely in place. The option that we've chosen on this boat is this bracket, which will mount near the foot pedal and raise the locator up slightly and position it directly in the center of the boat. This is a bracket made by Precision Sonar. We're going to position our nice little bracket in this position here. We will screw it down with some lag screws, or you can also through bolt it, and then we will align and attach our gimbal bracket on top of that, install the locator, and hook the plugs up. That will complete our installation of the boat. So let's finish up the last little bit of work. Whenever you're assembling a stainless bolt that has a nylon insert, a nice little trick, little A little Vaseline on the threads before you assemble it, and that will make sure that it protects and secures the nylon insert on the inside of the nut. The final part of our installation on the front, have our mount put together. You have the HDS-12 Gen positioned. Now we hook up the cables. Our SpotlightScan cable. Next in line, the blue plug, which is our sonar cable. The red plug, our power cable. The yellow plugs, our Ethernet network. The extra yellow plug, which we don't need, we will cap off with one of the supplied Ethernet plugs. And then finally, the very last is our NEMA 2000 network. Complete the assembly of the bow locator. We're ready to turn the locator on and begin doing some initial setup and adjustment work. We have the bow locator powered up. One of the nice things about the HDS Gen 3s is the auto configuration features, which are actually built into the software of the locators. As soon as we turn both locators on, the network is going to begin sensing all of the different components that we installed on the boat, and it's going to begin letting us know that it's identified and enabled all of the parts. For instance, here it says StructureScan 3D. It recognized our StructureScan 3D module and transducer and says it's been enabled. It's ready to function. We'll say OK. Navigational page comes up. Say accept, and it goes over to our chart. It says auto data source selection will be performed. Connect and power up all network devices. When we do that, when we power up our console locator, it will go through and automatically begin selecting the appropriate sources for sonar, GPS antennas, etc., all the items that we put on the network. First, we need to calibrate our position sensor to the type of foot pedal that we're using. In this case, it's a Minn Kota cable drive foot pedal. It has a number of different options for different foot pedals. And then secondly, we will actually train the sonar beams on the transducer for the SpotlightScan to align with the direction of our trolling motor itself and the trolling motor head. So from the main page, we will go to settings, scroll up, network, device list. When we look at the device list, it shows all of the different devices that we have attached to the network. The SLS-100 is the SpotlightScan NEMA device, which is a position sensor on the foot pedal. So if we go in here, we can name it. Spotlight. We can calibrate it. It says Motor Guide Tour foot pedal. We actually want to calibrate it to a Minn Kota foot pedal. Tell it to calibrate. It's calibration complete. So now we've adjusted the position sensor, the NEMA device, to the locator. Exit out of that. Exit out of that. Go back to our Spotlight page. And we see from the arrow on the trolling motor that the trolling motor head is actually positioned straight forward. But the beams here are shooting back behind us. So each of these lines represents the sonar beam that will now move as we move our foot pedal. So what we want to do is we want to go in and adjust these sonar beams so that they're pointing upwards to match the direction of our trolling motor. That is under advanced position adjustment. Position adjustment comes up as we slide. We'll move the beam to the top. So as we move the trolling motor now, this beam will actually follow the trolling motor. And our unit is now calibrated for proper use of the SpotlightScan. One caution, make sure the cables in your foot pedal are tight, because if there is slack inside those cables, that slack will show up in the movement of the SpotlightScan beam, and also it will make the SpotlightScan a lot more difficult to use. So whenever you're using this, make sure your cables are nice and tight and you don't have a lot of play in the foot pedal. In conclusion to our Lowrance installation video, just in summary, we have installed two HDS-Gen 12 locators. One was installed in the dash to show the process for that type of installation. The second one was installed on a precision sonar mount here in the front. We also talked about ram mounts for the bow of the boat. In addition to that, we assembled a SpotlightScan transducer on the trolling motor and showed how it was adjusted through the use of the locator, the calibration to the foot pedal. We installed a Point-1 GPS antenna and heading sensor in the transom of the boat. And then also, we installed the brand new StructureScan 3D transducer and module box. The module box was placed inside a secure and lockable compartment. We installed a complete NEMA network and a separate Ethernet network to handle all the network communications in the boat. One of the final steps to secure the locator here at the bow, for instance, might be an E-lock option by DuraSafe. Replaces the gimbal knobs, snaps into place, has a lockable key, and now you have your valuable locator securely locked to the front of the boat in case you don't want to remove it all the time. Just a nice product option for security. So that concludes the setup and installation of our double unit, double network Lowrance system.